Hello everyone, I am Piyush Wairale. So this is the first lecture for your AI syllabus for your GATE DA exam. So we are not focusing on the practical part of the AI because that is not required for a GATE exam point of view. We are going to focus on the conceptual part. Then we are also going to discuss the questions that you can expect from this particular topic. Now let's start the session. Now we'll start with the intro to AI, right? So we are not going into what is AI, the definition of AI, like what is the history of AI, how it is evolved. We are not going into that because I don't think that yet will ask such questions. So basically, what is AI, right? So AI covers a range of techniques or algorithm that appears as sentient behavior by the computers, right? For example, you must have seen self-driving car, right? Self-driving car. That is a good example of AI. Or you can see a recommendation on Netflix or YouTube or even Instagram Reels, right? So that is also part of AI. So they basically use AI algorithm for that. Right? For example, AI used to recognize faces in photograph on social media. For example, in Facebook, right? Whenever you upload, suppose a group photo on Facebook, so Facebook will suggest, okay, this is your friend, tag him. This is your friend, tag him, right? So this suggestion will be given by the Facebook, and this is also based on the AI, right? So AI algorithm is there. Now you must have read the news also, right? That AI beat the world champion in chess, and also the famous thing like Alexa and Siri. We all know about it, right? So we can interact with Siri and Alexa by using our phone, right? So we can simply speak, and the Alexa or Siri will give us the response according to that, right? So that is also part of AI. Okay, so I think you got the overall view of AI. What is AI? So here you can see a humanoid robot, AI robot. Now we will move towards our first topic, right? So that is search. So what is search and what is search algorithms in AI, right? So what do you understand by the search first? So searching is basically finding something, right? So finding what? So finding some solution of some particular task, right? So search is basically finding a solution to a problem, right? So in the AI context, we can see search is basically we're trying to find out like what step we should do, right? What is our next action should be there in order to reach a particular goal, right? So that can also be a search problem or search algorithm we can say, right? For example, you can say navigator app like Google Maps, right? Can find base route from your origin to destination, right? So if I want to go from Pune to Mumbai, right? So Google Map will suggest you few recommendation like two three routes, and based on their recommendation that this particular if you go by this particular route A, you will take this much amount of time, right? Or if you go by this particular route, there is some traffic also, right? So that suggestion this navigator app will do, right? Or playing a game or figuring out the next move, so that is also part of our search algorithm. Okay, so whole video is focusing on this particular topic only, right? Because this is the first topic in our GATE syllabus. Okay, now let us consider we have one AI player. Okay, AI player playing a puzzle. So this is the starting point. Okay, this is the ending point, right? Suppose this is AI player or some AI agent, AI algorithm. So in order to play this particular puzzle, what this AI should know, right? Just think about it. So the first thing is that AI should know how to play this game, right? But for that also AI should know what is my starting point is. So AI should know the starting point, right? That is initial state. AI should also know my ending point. I can say this is goal. This is my particular goal. I want to reach here, right? Or final state also you can say, right? And AI should also know like what action I need to take. If I go like this, then I should go in this way or this way or in this way or in this direction, right? So AI should know like in which direction I need to go and what will be my optimum solution for that, right? It's not like that I will go like this, like this, like this, like this. And if I found, okay, I am stuck in here, then I'm going back and going like this. So we should know what is the optimum way to reach from the starting point to the ending point, right? So AI should know there are three things: initial state, the final state, that is our goal, and what are the actions that AI needs to perform. Or whenever I say AI, it means our search algorithms. So what are the actions do AI needs to perform in order to reach their final state? So that also we need to tell them, right? So then only this AI will able to play this game, right? Okay. Now let's go to the next slide. Now let us see. Now let us discuss one more puzzle, say game. Okay. So this is our 50 tile puzzle game, right? So this is our initial state. So many of you have played this game, right? So we need to convert this particular initial state to the final state. So what is the final state? One, 2, 3, 4, 5, 6, right? Till 15 in the particular sequence. So this is what we are trying to achieve. This is our initial state and this is our final state. This is our final state, right? Now let us try to understand this particular search problem concept by using this particular example. Okay. Now this is my initial state. This is my final state, right? I want to go from this to this, right? So how this AI player or AI algorithm will do this particular task, right? Now let's see that. So first we'll see what are different terminologies are there, right? For example, agent. So what is an agent? Agent is any entity that perceives its environment and acts upon that environment. Now what is entity? What do you understand by pursue its environment? Now what is this acts upon that environment, right? Let us see one by one. So what is entity? So basically entity refers to any object or thing that exists in particular given context, right? Say for example, computer program, right? You can see computer program is particular entity or any system or any system designed to perform any particular task, right? Designed to perform any task that can be also an entity. Now, what about this pursue its environment? What do you understand by this? So basically, this means that this particular entity is capable of sensing or gathering the information from the surrounding, right? Or the context that it is going to operate. For example, like our AI humanoid robot will have sensor, cameras, and and maybe some other components also, which will collect the data from its surrounding, right? Now, once we collect the data from the surrounding, now this particular entity or agent, we can say, will act upon that environment, right? So once you gather the data, it will take the action or make the decision based on the information it has gathered. So this is what agent is. So for example, you can say navigator app, right? So in this case, the agent will be say some software component, right? Used in this particular navigator app, or agent would be a representation of a car that needs to decide or which actions to take arrive at destination, right? So that's what we have discussed in the previous slide, right? So like the agent will be our software component, right? Suppose if I want to go from Mumbai to Pune by using self-driving car, right? So in this case, my agent will be a self-driving car or any software component or AI algorithm can also be of my agent, right? Let us consider the self-driving car is my agent. So what is the environment for this particular self-driving car? So it can use the data from GPS, right? Maps, or you can say maps also, or possibly real-time traffic also, right? So real-time traffic also. Based on this input, this particular self-driving car will decide, okay, whether I need to take left turn or right turn. If I take left turn, then how much time it will take to reach my destination. If I take the right turn, then how much time it will take to reach my destination. So all those things will be considered as a pursuit is environment and acts upon that environment. I think this definition is clear to everyone about the agent, right? Now let's move on to our next part, that is the state. So state can be any configuration of an agent in this particular environment. So if you go back to a previous example, say for this example, Mumbai is my initial state and Pune is my final state or goal state. If I'm going Mumbai to Pune, say this can be my initial state, this can be my state, this can be also my state. So any configuration, or in this case, you can say any destination or any point, I can say that is basically my current state, right? So configuration of an agent in its environment, we can say a state. For example, for example, in a 15 puzzle if a state is any one way that numbers are arranged on the board, right? So for example, if I move this state on the left hand side, that will be a completely new state because then the state will move here and here we can get an empty space, right? So it will be an in new state. So these all are the different state of this particular puzzle game, right? Now, what is initial state? So we should know, so our AI algorithm should know what is my initial or what is my starting point is, right? So state from which the search algorithm will start, that is basically an initial state. So for our example, for 15 puzzle example, we'll consider this is as an initial state. Okay, this as an initial state. And our goal state is to convert this particular puzzle into a particular order. Say 1, 2, 3, 4 like this till 15, right? Now, what is actions? So actions are basically choices that can be made in a particular state. So for example, this is my initial state, right? Now what are the possible actions I can take? Whether I can move this particular one tile, so this tile down, or I can move this particular 10 tile on the left hand side, 6 on the right hand side, or 15 above, right? So I can do so I can perform four actions here, right? I can perform four actions here. Right, so that can be considered as an action. So the choices that can be made in a particular state that can we can say it is an action. So an AI algorithm can take four action here, right? So it can either move the one down, 15 up, or 6 or 10 left and right. Okay? So more precisely, actions can be defined as a function. So basically, action is a function upon receiving a state as input. So the state as an input. So action is basically a function which will take this as a input, right? And it returns the output at a state of actions that can be executed in a particular state, right? So we'll discuss this with the help of example. I hope you understand what is action, like what are the possible choices that any such algorithm can take from a particular state, right? Now, what is transition model? So this is important thing. So basically, suppose we are in a particular state and we are performing some actions, right? So upon receiving a state as an action A as an input, so basically this result is a function that is we will take as a state as an input and action as an input, right? So it will return the state resulting from a performing action A in a state S. Right? Say for example, in a 15 puzzle game, moving the square in any direction, that will be my action. That was so that what we had discussed will bring to a new configuration of a puzzle in a new state, right? So from going to one state to another state by performing some action, that I can say a transition model. Okay, so for example, here you can see this is one example. This is a result function. This is my one of the state, and this is my action, right? So if we perform this action in this particular state, so what I will get, this is a completely new state. So this I can say it is a transition model. Same one, this example, I can move the slide down also, so I will get another new state, right? So whenever you perform any action in a particular state, so you will get a new state, so that we can say transition model, right? So this is basically a function, which will take state as an input and action, right? I hope you understand what is transition model. Now, what is state space, right? So, in the probability, you must have discussed about what is sample space, right? Sample space. So, like all possible outcomes of an event, right? That is basically a sample space. So, if I am tossing a coin, toss a coin. So, basically, there are two possibilities, right? It will be head or tail. So, there are two sample space for this particular event. Right? Similarly, here also, the set of all states reachable from a particular initial state by any sequence of actions that can be called as a state space. For example, in a 15 puzzle game, the state space consists of all the 16 factorial by 2 configuration on the board that can be reached from any initial state. Right? So this much number of configurations are possible for this particular game, right? So that is basically my state space. So here you can see this is my one of the states. So it's initial state, right? And I'm performing some action here. I'm getting a new state. Again, I'm performing some action. I'm getting a new state. Again, I'm performing an action, right? So in this way, I can get a new state. Similarly, here also some state will be there and performing some action here also, right? So it goes continuously. And how many possible states are there? 16 factorial by 2, right? So that is basically a state space, and we are representing like this: those state and action, right? Now, whatever we have discussed in the previous slide, so same state space can be utilized as a directed graph also with the states, with states represent as the nodes and actions represent as arrows between nodes. Here you can see I can convert this image, this particular graph into this particular directed graph. So this can be my initial state, this can be my final state, or this can be my final state. Here you can see, so each states represent a node, right? So here you can see each node represent a state, and here you can see this particular action. So we are getting a new state here, right? So we can represent this so we can represent a particular state space in with the help of directed graph, right? Now, what is goal test is? So, as we already discussed, the condition that determines whether a given state is a goal state, right? So, in this case, suppose if I want to reach here, then how will AI algorithm or such algorithm will know? Because I want to reach here only. For that, he should know, okay, this is my goal, this is my end state, right? So, same thing is there. That is a goal state. So, our condition is that so our AI algorithm should know that whether a given state is a goal state or not, right? So this is our the goal state, right? This is our goal state for the particular problem. Now, what is path cost? I can reach. So if I consider this example, I can reach f by any means, right? I can go like this also. I can go like this also. I can go like this also, if possible, right? I can go in many ways. So reaching to a particular place, so that will be my solution, but that is not the optimum way, right? So for that, we should calculate the path cost, right? So what is path cost? A numerical cost associated with a given path, right? So for if I go by this particular path, it will take this much amount of effort or resources, you can say. If I go by this path, it will take this much amount of resources. So I should able to calculate what is the path cost for that, right? For example, a navigator app does not simplify brings to your goal. It does so by minimizing the path cost, right? That's what Google Maps suggests us, right? It's finding the fastest way possible for you to get your goal state. So here you can see the same graph we are represented by nodes and action, right? For a given particular problem, for a given problem of 15 puzzle, we can take only one action at a particular time, right? So my resource will be for a particular action will be one only, right? For this 15 puzzle game, right? There may be some other tasks or other puzzles where I need to spend more resources for each particular action. For this example, if I want to go from C to A, I need to spend two resources. If I want to go from C to H, I need to spend three resources. So depending upon the task, our cost will vary, right? Now, the solution, a sequence of actions that leads from initial state to goal state. That is basically a solution. From reaching a particular state from point A to point B is a solution, but it may not be optimum solution, right? We can go like this, like this, like this also. We can go direct like this also. We can go like this also, right? But reaching a B is a solution, but it should be an optimal solution, right? So what is optimal solution? A solution that has the lowest path cost among all the solutions, right? So that will be my optimum solution. So I hope you understand what we have discussed in today's lecture. So there are basic components of any search algorithm or search problems. So first we should know, like our agent should know what is initial state, what are the actions needs to be performed, and what are the transitions, like how it will move ahead. Then what is the goal state, what is the path function, what is path cost function, and what is the solution or optimum solution, right? So these are the few components of a search problem, right? I hope you understand whatever we have discussed till now. Right now, let us try to discuss one example. So before discussing one problem, let us see what is node here. So node is basically a data structure that keeps a track of a particular state, right? So we have seen this graph like this directed graph. So node is basically a data structure that keeps a track of a particular state, right? This is also state, this is also state. A parent, right? It is also a parent node because node that generates this node, right? So for example, this is a particular initial state and we are performing some actions, right? And we are reaching to this new state, right? So this node is newly formed, and this node we can say that it is a parent node, right? And an action, so the action applied to parent to get a node. So we are performing some action applied to parent to get a particular new node, right? A new state we can say a path call from initial state to node, right? So there are a few things. Just keep a note of this. Okay, now let us consider one approach here. Right? Suppose we have given a graph and we want to find out some element. So how we are going to approach that particular problem? Okay, so start with the frontier that contains the initial state. So frontier is basically you can say a mechanism, right? You can say it is a mechanism to manage the nodes, right? To manage the nodes, right? So basically, which node we have to go like from if I'm on this particular node, whether I should go on this node or this node, right? So that's basically we can say a frontier or mechanism to manage the node, right? So this is basically our important steps. What we can do if the frontier is empty, then there is no solution, right? So if I reach here and I don't have any further path to go, so we can say there is no solution. Then we can remove a node from the frontier. If node contains goal state, then return the solution. Then expand node and add resulting nodes to the frontier here. Okay. So just go through it. We're going to discuss with the help of example. Okay. Okay. Now let's see. Let us consider this particular question, right? So we have to find a path from A to E, right? So how we are going to proceed this with the approach that we have discussed in the previous slide. So our first starting point is A, right? Now from A I can go to B. So my frontier is B here. Now I am going to B. Now I have two frontier in this case. Either I can go for C or D. Okay? Now let us consider I am going for the particular C node, right? I go to C node, right? Then what is the frontier for me? For this particular node C, E. Okay? Then my next frontier will be E. Then I will go to a next node that is E. So then I will say, okay, whether this is my required state or not, right? So yes, this is my required state, right? If a node contains goal state, then we can say then it is my required state and will return to the solution, right? So this is our required solution, right? Now here you can see the goal constraints. If the nodes contain a goal state, then we can say returns to the solution, right? But the approach that what we have used in this particular problem, so what could go wrong in this case? Just think about it, right? So for example, I'm at a node A, my frontier will be B, right? I am going to B. But now I can also go back to A also. Like so previously we know this is directed graph, like I can go C and D. But how algorithm will know? Like he can also go back to A. Some same thing. This can happen for infinite times. We can go back to A, then B, then C, then again back C to A. Like this it will happen. Like this it will happen. Right? So we're going to revise our approach. Right? So what is our revised approach? So we'll start the frontier that contains the initial state. Then start with an empty explored state, right? So whatever the state we already explored, whatever the node we have already explored, that we are going to note of it. That we are going to keep a note of it, right? Well, this is the algorithm that we are going to follow. If the frontier is empty, then no solution. Remove node from the frontier. If node contains goal state, return the solution. Add the node to the explored state, right? Then expand the node, add resulting node to the frontier if they aren't already in the frontier or set explored. So this may sound little confusing, but don't worry, we are going to discuss one problem. So that's the same thing. Okay, just go through it. Nothing in that. So there are a few basic data structure terminologies you should know. So one is stack, that is last in first out data type, right? By using this stack data structure, last in first out, right? What we are saying, first our initial state is A, right? Then our the frontier is B here, right? When I'm going to when I'm going to node B, we already explored the state A. Here you can see, right? Now, when I reach the point B, now my frontiers are C and D, right? Because I already explored A state, right? And we are following the stack data structure here. That is last in, first out. Now I can go for C, I can go for D also, right? I'm going for D. D came last, right? If the C came last, then we can go for C also. Now my next frontier will be F. I will go to F, right? Because that is my last visited node frontier, right? Now I will try to compare, okay, whether this is my goal state or not. No, right? Then again, I will see what are the nodes I have didn't explore. That is particular node C, right? Now then I will move on to a C because that is my next frontier. Once I reach the node particular C, then I have only one node to explore. That is E, right? That is my next frontier. Now when I reach E, so okay, I find a particular node, so I can say my particular traversal of a path is over now. I found my goal state, that is E, right? So this is something we call as step first search algorithm, right? So this is a part of uninformed search algorithm. This is the part of uninformed search, so which is the part of our syllabus. Okay, so if we go to our syllabus, yes, so this is our syllabus. Here you can see in the search topic we have informed search strategies, then we have uninformed, right? And then we have adversarial, right? So whatever we have discussed in this particular lecture, it will cover the basic fundamental foundation for this particular search algorithm. So whatever we have discussed just now, it is a part of the first search that comes under uninformed search strategies, that is depth first search, right? That is DFS. We have breadth first search, that is BFS, right? In informed search strategies, we are going to discuss about greedy best first search. Then we have A star search, right? So there are different searching strategies in the AI syllabus that we are going to discuss. In the case of adversarial search, we are going to discuss about minimax. Then we have depth limited minimax. Okay, and then we have something like alpha beta tuning, right? So if these are the different strategies that we are going to discuss as a part of our GATE syllabus. So we have discussed the foundation knowledge required for this particular topic search. Now in the next video, we are going to discuss about depth first search and breadth first search in detail. Then we are going to discuss about informed search, greedy based first search method. Then we have A star search, and then we are going to discuss about adversarial search strategies, minimax, depth limited minimax, and alpha beta tuning. Okay, so this will cover your first part of your AI search AI search problem. It's AI search strategies. Okay. If you understand whatever we have discussed today, you will be able to understand all the search strategies. Okay. So we are going to go in that same flow only. Okay. So you can watch this video twice also to understand in a better way what are the different terminologies we are using, and particularly the last example we have seen. Okay. So please try to uh, understand it carefully. Okay, go through the slides. Okay, I will provide these slides on my Telegram channel, so you can join my Telegram channel. I will provide the link in the description. You can just go through it, right? So this is how we are going to proceed for our AI Gate syllabus. Okay, so that's it from my side. Thank you, everyone. Thank you.